Hydrocarbons. The hydrocarbons are separated in alkenes, personal alkanes, alkynes, and aromatics. They are varying in the number of bonds that they have. If they have double bonds, they are alkenes. If they have triple bonds, they are alkynes. And if they have a benzene, they are aromatics. We will be showing how to name them and how to draw them, each one of them.
Well, in this video I showed the steps to name alkanes based on the IUPAC system, and well, start. We have this structure and it's alkane. Why is alkane? Because you see that lines is a bound, and you can see it's a single bound because it's only have a one line. And well, what is your first step is count the number of carbons in the longest carbon chain. Well, you can count the number of these carbons like 1, 2, 3, 4, 5, 6, 7, 8, and to this point is 8 carbons, but you need a longer number to 8, so we try to start in this point, like is 1, 2, 3, 4, 5, 6, 7, 8, 9. Well, 9 is a bigger name than 8, so we can use this. So this is the structure we can use. And then the second step is number each carbon giving all substance lower numbers. So you need to put a number, and but the question is I started in this point or in this point. Well, if I started in this point, is a 1, 2, 3. But if I started in this point, it's 1, 2. So I need to start in this point because it's lowest number. So only need to number 1, 2, 3, 4, 5, 6, 7, 8, and 9. Well, in this case, we can say this structure has a 9 carbons. So if we see that this table, number 9 is represented by none and is alkane, so we can add an A to the E, N, and no, well, sorry, A, N, and A, because it's alkane. So it's not named. This structure has a 9 carbons, so if we see that this table, number 9 is represented by none and is alkane, so we can add an A to the E, N, and no, well, sorry, A, N, and A, because it's alkane, so it's not named. So started put no name. Well, then is the name substance. You need to name the substance, and you can see these carbons is a 3, yeah, and these 3 and this carbon are in the place 2, 4, and 7. So you put 2, 4, comma 7. It's important to put a comma because if you put a line, is meaning other thing. Well, 1, 2, 3. So it's try. And it's a methyl. Yeah, 1 carbon is a methyl. So methyl. So it's 2, 4, 7 trimethyl nonane, and this is the how you can name alkane by the IUPAC system to name alkane. Okay, doesn't matter. In this case, I draw to the bottom and then put 3 carbons because it's propyl. The next step is to view this number 2 and 3. That is meaning is something in 2 and 3. So we can see D, that is meaning the 2, and methyl, that is meaning 1 carbon. So I draw here a line that is carbon with a CH3, and then because it's in the level 2, so in the level 3 are other methyl because it's D. So draw bonds and then add CH3, that is a 1 carbon, and well, this is the structural way to draw a alkane with this name, and then you only add the H to all carbons. And this is the form, or this is how you can draw the structural form to a alkane, and only add the H and the numbers.
Alkynes. What are alkynes? Alkynes are organic molecules made of the functional group carbon-carbon triple bonds. They are written in the empirical formula of CnH2n-2. This is an example of an alkyne, and this is another example of an alkyne. These two have triple bonds, and that's why they are alkynes. Rules for naming an alkyne. We first identify the triple bond, then the biggest chain including the triple bond, then we identify all the substituents and we name each one of them. At the naming part, we place by alphabetical order all the substituents with their positions, and then the position of the triple bond plus the name of the longest chain plus "-ine". This is a lot to take in, but it's easier with an example. How to name an alkyne. This is the example of the alkyne we looked at before. We first identify the triple bond, and that's there. Then the biggest chain, and we can also see this chain that's bigger than this one, but because it doesn't have the triple bond in it, then we can discard it. Then the substituents, we have this one, this one, this one, and this one. We then need to name them because this has 3 carbons, it's a propyl, and these 3 are methyls. Then at the naming part, we place by alphabetical order. This is the methyl, and this is a propyl. First goes methyl, so we have 3 methyls in positions 3, 5, and 6. So it's 3, 5, 6, 3 methyl. Then we put the 3 propyl because it's in the position 3, in the propyl. Then the position of the triple bond plus the name of the longest chain plus ine. The position of the triple bond is in the position 1. Then the name of the longest chain is hept because it has 7. Then ine because it's an alkyne. So it's 1 heptine. So at the end, what we have is 3,5,6 trimethyl, 3-propyl, 1 heptine. Now, rules to draw an alkyne. The longest chain has to be identified and drawn. Then we draw the triple bond that is in the longest chain, and then place bonds in the substituent places where the substituents are supposed to go, and then put the substituents at the end, following the rules of order. How to draw an alkyne? 3,6-dimethyl 2,5-nonadiene. Because it has a D and 2 on 5, we can assume that we have 2 triple bonds. We can draw the longest chain and the triple bond. The longest chain is 9 carbons because it's a nonadiene, and we have the triple bonds and 2 on 5. That's what we have at the end. And then we place the bonds in substituent places, that means 3 and 6, and we put the dimethyls in it, so it's a methyl here and a methyl here. And that's it for
our last type of molecule are aromatics. Aromatics are a hydrocarbon with alternate ring, double and single bonds between carbon atoms forming rings. This is a way to represent it. We have 1, 2, 3 double bonds and 1, 2, 3 single bonds. But since they are alternating, they are making circles all around. So we prefer to represent it like this. When naming aromatics, we have 3 different cases. The first one is with one substituent. Here we have 2 options. Use the UPEC system, the system we already saw, where we don't need to put numbers since we only have one substituent and that will always be the 1. With these methods, in this case, the correct naming will be methylbenzene. We know that this here is the methyl and this is the benzene. We identify our parent chain, that is the benzene, and then put the methyl. The second case is the common names. Not all the aromatics have common names. These are special names pre-established that you need to learn. The name for this aromatic will be toluene. When we want to name an aromatic, and we can identify it's a substituent because we lack a number here. It's a one substituent case, we don't have a number. So here, in this case, if we wanted to draw this, we will just put the benzene and then the methyl. If they gave us the name, we would need to know the name for drawing a one substituent benzene. Our second case would be a two substituent case. Here we have 3 options. Use numbers, prefixes, or common names. Numbers is the method we just saw. We identify our parent chain, then we identify our substituents. Here, the correct naming would be 1-isopropyl 4-methylbenzene. We use alphabetical order. I is before then M, so it's 1, 2, 3, and 4. 1-isopropyl 4-methyl. When we want to use prefixes, the prefixes are for determined positions of the substituents around the benzene. In this case, we would use para because we get in position 1 and position 4. Position 1 and position 4. The correct name would be para-isopropyl methylbenzene. We could only put a P to abbreviate the whole name. That's just enough. When we want to use common names, we need a common name. If we don't have a common name for our benzene, we can't use this method. Here we know that CH3 with the benzene is called toluene. So we will put 4-isopropyl toluene. Why 4 if it's 1? When we use the parent chain as toluene, CH3 automatically becomes 1, and then we name 2, 3, and 4. So it would be 4-isopropyl toluene. We could combine common names with prefixes. When we do this, this 4 can be substituted by the P. Since the methyl it's already in the 1, it would be P isopropyl toluene. When we want to draw this type of benzenes, we need to identify the two substituents. Here we know that's 1 and 4, isopropyl and methyl. We'll draw first our benzene, then put the 1 where we want and put the isopropyl, then the 4 when we want and put the methyl. When we get the para, we already know that P is equal to 1 and 4. So again, we draw our benzene, then we put our methyl in the 1 and our isopropyl in the 4, or the other way. When we found this kind of name, the 4-isopropyl toluene, we need to know what toluene is. So we would be able to draw the toluene and then count 4, 1, 2, 3, 4, and put the isopropyl. And in this case it's the same. We need to know the prefix that is para to know that's 1 and 4, and we need to know what's toluene. So we draw our toluene, then we count 1, 2, 3, 4, and draw our isopropyl. At last but not least, we got our third case, the 3 or more substituent case. Here we have two options again, numbers and common names. In numbers, we will number with the most convenient way, so here it would be 1, 2, 3, 4, 5, and 6. We number it this way because we get the lowest values. Now, we need to put it in alphabetical order. This is nitro, and this is methyl. M goes before then N, so the name would be 2-methyl because it's in the 2, 1, 3, 5, trinitrobenzene because it's in 1, 3, and 5. The second option is the common names. We need to have here again a common name. If we don't have, we can use these options. We know that methylbenzene it's toluene. So we put a 2, 4, and 6 trinitrotoluene, aka TNT, because when we do the toluene, we give more importance again to the methyl. So this automatically becomes 1, and then we name again 2, 3, 4, 5, and 6. So it would be 2, 4, 6, 2, 4, 6, trinitro, because we have 3, toluene, because we have the toluene. When we want to draw this kind of substituents, we first of all need to identify the benzene. We draw our benzene, and then the number of substituents we have. Here we know that it's 2, 1, 3, and 5. We know that we have 4. So we put the 1 when we want, and we know that it's not nitro. So we put 1, 3, and 5. And then put our methyl. When they give us this kind of name, the 2,4,6 trinitrotoluene, we need to know what's toluene. We draw the toluene, and then in the positions 2, 4, and 6, we identify the different substituents, knowing that methyl it's always going to be in the 1 because it's toluene. So 2, 4, and 6, and we put our nitro.